This lesson deals with supplemental problem 313. You can find this problem in the course ebook in the Chapter 3 supplemental problem starting on page 16. Given the circuit, which has 4 resistors, an independent voltage source, and a dependent voltage source, can you solve for the current I using the mesh current method? This is a 4-step algorithm that was in our class notes. And the first one is to pick the mesh currents, and they've already been picked for us to be clockwise. The second step is to apply Kirchhoff's voltage law. For me to do that, I need to assign a polarity to each of the resistors. I like to pick it in the same direction of the mesh current, but you can pick it any way you want. I'll call this plus and minus. I'll call this plus and minus, just kind of following I1. Call this plus and minus, following I2. Plus and minus, this is already plus and minus. This one's already been assigned, following I3. Again, it's arbitrary. Once you pick it, just stick with it. Going around mesh 1, the rise in voltages equals the drop. Let's start here. Around the mesh this way. I've got a drop of the current in this resistance times 4, and that's going to be in this direction. So it's going to be agreeing with I1, disagreeing with I2, so it's going to be I1 minus I2 times 4, and then just going to have I1 going in this direction times 4, and then a drop of 20 I1. So I've got 4 times I1, 4 times I1, and then 20. So I've got 28 I1 and then minus 4 I2. I have one equation of my 3 unknowns. I really have 0 times I3. Going around mesh 2, let's start here. The rise in voltage equals the drops. The rise in voltage is the voltage across the 4 ohm resistor, and we said that was I1 minus I2 times 4. And then the drop in the current in this direction is I. That's going to be equal to I2 minus I3. So it agrees with I2, disagrees with I3. I2 minus I3 times the 8 ohms. And here I just have I2 flowing in this direction, so I2 times 10. We have no constants. Put everything on the other side of the equation. So we've got 0, and then I've got I1 times 4, which becomes a minus 4I1. And then I have minus 4I2, which becomes a plus 4 times I2. And then I have 8, and I have 10. That gives me 22I2. And then I have a minus 8 times I3. Lastly, going around mesh 3, I'll start here. The rise in voltage equals the drops. The voltage across the 8 ohm is a rise. The drop across the 4, the drop across the 36 volt battery. Found that this current was equal to I2 minus I3 times 8. That's our rise in voltage. The drop is going to be I3 times 4 and then 36. Put our constant on the left hand side of the equation, so it's minus 36. 8I2 on the other side of the equation becomes a minus 8I2. This will become a plus 8I3. Plus 4I3 is 12I3. I have 3 equations and 3 unknowns. Put this in matrix form, so here's our first equation. We have 0 is equal to 28I1 minus 4I2 plus nothing times I3. Our second equation is that 0 is equal to minus 4 times I1 plus 22 times I2 minus 8 times I3. And our last equation right here is minus 36 is equal to 0 times I1 minus 8 times I2 and then plus 12 times I3. Since we're dealing with 3 by 3 matrix, we should use our calculator or maybe MATLAB. I'll call this V is equal to R times I. My voltage is our 0, 0 minus 36. Hit enter and it echoes back my column matrix. And I'm going to call this R. I have 28 minus 4 and 0. Second row, minus 4, 22 minus 8. Third row, 0 minus 8, 12. Hit enter and it echoes back the matrix. Again, if these aren't correct, just use the arrow key to go back and correct it. And we're going to solve for the current. This is a matrix. The matrix I is going to be R divided into V. What is a matrix? Hit enter and you get the 3 answers, I1, I2, and I3. But the current we're solving for I is just I2 minus I3. I'm just going to mark those 2 here. So it's a minus 1.4911 minus a minus 3.9941. And it turns out to be 2.503. And this is supplemental problem 313.